Hi guys, so today I'm going to share with you the summary and what I've learned from the embedded systems internship offered by the EMATS Information Technologies. So I'll start by sharing my slides for the summary. I'll open them. Okay, sorry, they are taking a while. It's taking a Okay, I have already opened my MPLab XIDE because it will definitely also take some time, and my PixSim lab is also ready. So I'll go straight to my presentation. In my presentation, let me go to the slideshow from the current slide. Okay, sorry. So this is embedded systems internship summary. The project we built was the car black box project, prepared and submitted by Jackson Malabi, a student, a Bachelor of Science in Electrical and Electronic Engineering, the Kimathi University of Technology in Kenya. Okay, the content of the presentation is 1. The internship overview, the setup of resources, recap of C programming, project requirements and design, building the units, which are peripheral programming, project integration and testing. Internship overview. An introduction to the internship was done, highlighting the objectives to be achieved. The internship period was set to be 4 weeks, which turned to be 8 weeks. The objective was to make a car black box system that can record events of a car and store them for reference when needed. To achieve this, C programming was the language to be used because of its advantages in communicating with peripherals. Objective point 2, setup of resources. The resources used were: number 1, MPLab XIDE, installation of PixSim Lab, and also an online learning, online LMS portal was created by the EMATS Information Technologies, and we were given access to login so we can follow through the internship. The recap of C programming. The recap of C programming, introduction to C programming and its data types was done. Conditional constructs and operators, operators and arrays, pointers, functions, recursion, construct qualifier and strings, storage classes and preprocessors. Then there was project requirement and design. The project schedule was done, and the project was set to be done in 3 weeks, as in which 2 more weeks were added. There was also an introduction to microcontrollers as the requirement for the project. Building the units peripheral programming. Peripheral units of the car black box were timer, 16:2 LCD screen, and analog to digital converter. All these were integrated in an a software simulator called the PixSim Lab, which we used to build the project. Project integration. The steps of implementation were: first, implementation of the dashboard, then the main menu screen, view log screen, clear log screen, change password screen. Continuation of the project integration. The dashboard by default displays time, event, and speed of the car. When the car is switched on, time is obtained from the RTC. event obtained from the tactile switches, and the speed recorded from the ADC. Events to be recorded were on C, GN, GR, G1, G2, G3, G4. The event abbreviations are ON for car engine on, C for physical collision, GR for reverse gear, GN for neutral gear, G1 for gear 1, G2 for gear 3, and G4 for gear 4. Finally, the project testing was done using the PIC SimLab simulator. Each step of the project implementation was tested before moving to the next step. The simulation of testing was recorded, and it is available in the YouTube link. Thank you. Okay, so we will now go straight to the, let me close this first. We will go straight to the testing, whereby the programming was done using the PIC SimLab. Here is our project, the car black box project. It contains the header files, important files, linker files, source files, and okay, in our source files, here is the list of source files, and also we had a header file which consists of all headers used in the project. So we will first build this project. We will first build the project and clean the existing files. Okay, the project is now building. Let's wait for the project to build. The project is still building. The project is still building. Okay, my laptop is a bit slow, but it will definitely work. Okay, so after building the project, we now go to the PIC SimLab, where we reload the last saved file of the hex file. It gives us the time, which is 8:26 p.m. Okay, so we'll go straight to the, so now it is displaying the dashboard. We'll go to the, when we press switch 3, it asks for enter password to see the view logs. My password is 24. Okay, we can now view the logs, clear logs, change password. So we will start by viewing the logs. Okay, for now let's first create some logs. Okay, we are changing the gears, some collision there. Yes, so to view the logs, press switch 3, then you enter the password. After you enter the password, you click 5 for okay. Here are our logs. You can scroll down to view the logs. Then after viewing the logs, another function is clearing the logs. We can clear the logs. Logs cleared successfully. Then after another function of the project is changing the password. We click OK, switch 5, enter new password. Let me enter 222. I re-enter 222. Password changed successfully. Okay, another function of the, so summarily that is the objective which was achieved. So that is what happens when you enter a wrong password. Then after 3 seconds you get another chance to put your password. When you put another wrong password, 3 seconds, another chance to, so when it fails you go to 69 seconds before you can be able to, you wait for another 60 seconds before you can be able to access the login screen. Thank you.